Hey everyone, today we're going to talk about graphing systems of linear inequalities. So yesterday we did some problems where we had just compound inequalities and just straightforward linear inequalities. Here we're going to talk about systems. This unit we did earlier on in this semester, so hopefully this will be somewhat familiar to you already. But in this first example problem, we're going to go ahead and graph the following inequalities. And it says shade the region on the coordinate plane where both inequalities are true. Remember that that is where our two shaded regions overlap. Okay, so that's where that's the part that is true for both. Okay, so let's start with this first one. X is greater than or equal to 2. Now, when you just have an X in here, and there is no y, that would just be a vertical line at 2. So I'm going to go ahead and draw a vertical line at 2. And let me move that over. And the reason it's a solid line is because it's greater than or equal to. If it was just greater than, then that would be a dotted line, but since it's greater than or equal to, it's a solid line. And because it's greater than, I have to shade to the right. So I would be shading everything to the right of that. So that would be everything over here. Would be part of that inequality. Okay, now the next one is x plus 3y is less than 12. So I have to put that into y equals mx plus b form so that I know where to graph the line, and then I'll deal with the shading. So the first thing I'm going to do is subtract x from both sides, and that gives me 3y is less than negative x plus 12. And then from there, I'm going to divide everything by 3. So that would give me y is less than, and I'm going to rewrite this. Instead of writing it as negative x over 3, I'm going to write it as negative 1/3 x and then plus 4. So these two terms are equivalent to each other. It's just another way of writing it. And the reason I wrote it this way is because that's my slope. It's easier to graph it that way when I can see my slope. Okay, so I'm starting my line at 4. And my slope is negative 1/3, which means I go down 1 and over 3, down 1 and over 3, down 1 over 3. Okay, now because it's just a less than symbol, my line should be dotted. So when I go ahead and do that, there's my dotted line. And there would be my line right there, and that's my dotted line. Now, because it's less than, I'm going to shade below, right? Greater than is above, less than would be below. So I'm shading below. And where those two shaded regions overlap is the area where both inequalities are true. So if I go ahead and oops, let me go ahead and kind of highlight that part. So that would be all of this right in here. That's where my two shaded regions overlap. Is right there. If you wanted to, you could put a big S there. Whoops. Put a big S. That's where my solution set would be. Okay, so quick review of that. We're going to do a couple more problems. In this second example, same idea. Our first inequality is already in the right form to go ahead and do that. So I start at 1. My slope is 2, which means I go up 2 and over 1, up 2 over 1, up 2 over 1. Because it's just greater than, my line would be a dotted line. So here's my dotted line. And in my second equation, oh, let me go back. Sorry, let me shade my first one. In my first one, it's greater than. Remember, greater than is above the line, so I would be shading all of this over here. And again, you don't have to go crazy with the shading, just to get a general idea. Okay, that second equation then, right now it's not in the form for me to graph it yet. So I have to get it in y equals mx plus b form. So the first thing I'm going to do is subtract that 2x from both sides. And that gives me negative y is greater than negative 2x plus 4. Now, because I have this negative in front of the y, I have to get rid of that, which means I have to divide everything by negative 1. Remember, when you divide by a negative, you have to flip your inequality. So this is going to become y is less than positive 2x minus 4. Okay. So if I go down to negative 4 here, and my slope is positive 2, so I go up 2 over 1, 2 over 1, up 2 over 1, up 2 over 1. And if I go ahead and graph my line, now if you notice, our two lines are parallel to each other. And if you remember back when we were talking about writing equations of lines, we said if the slopes are the same, those lines are parallel. So they both have a slope of 2, which is why they're parallel. Okay. Now the second one, I still have to shade it. It says y is less than 2x minus 4. Okay, so if y is less than 2x minus 4, that means I shade below the line, which means I would be shading here. And there is no region where both inequalities are true at the same time, so you would just leave your graph like that. There actually is no solution to this system of inequalities because they don't overlap each other. Okay, there's no value that would satisfy both of those inequalities at the same time. Okay, so you might have a situation where your regions overlap, and you might have a situation where they don't. Okay, let's do one more. We'll graph the solution set of this system. So if you notice that first equation, I'll rewrite it down here. It's not yet in the form where I can graph it. I have to solve it for y. So the first thing I'm going to do is subtract x from both sides. Gives me 3y is less than negative x plus 6. And then to get y by itself, I'm going to divide everything by 3. So that would give me y is less than, and this is the same situation we had in one of the previous problems. Instead of writing it as negative x over 3, I'm going to write it as negative 1/3 x. And then 6 divided by 3 would be 2. Okay, so I'm going to go ahead and plot that one first. So I start at 2, and my slope is negative 1/3. So I go down 1 over 3, down 1 over 3, down 1 over 3. And it's strictly less than, so my line is going to be a dotted line. So there would be my line, and because it's less than, I shade below the line. Okay. Now let me go to this second one here. This is y is less than or equal to negative 1/3 x minus 3. So I'm going to start at negative 3. And again, if you notice, these two have the same slope. So they're going to be parallel. So I go down 1 over 3, down 1 over 3, down 1 over 3. And when I put my line in there, there's my other line. And it says y is, oh, back up. That actually should be a solid line because that's less than or equal to. My mistake, so let me redo that. So that should be a solid line. Right there, that should be a solid line. And because it's less than, I'm shading below that, so that is going to be down here as well. And so you can easily see here where our two shaded regions overlap. And that would be all this area in here, right, is where they overlap. So I'll just highlight it so you can see it a little better. That's our region where they overlap. Okay, and again, you could just put a big S in there to show that you know that that's where the solution is. And again, the solution can be any point in that region, right? I could pick the point -5, -4, or I could pick the point 6, -8. Either one of those satisfies the solution, or satisfies the system, because it's in the shaded region of both inequalities. Okay, one last problem. This one isn't graphing, but this one is a word problem. And it says an administrative assistant calculated that he spends more than 13% and less than 17% of his working hours in meetings. This can be represented by the system of inequalities shown below, where M represents the number of hours spent in meetings and H represents the total number of hours worked. A lot of words there. Okay, but we'll start with the fact that we know we have these two inequalities. Okay, they gave us that. It says that the administrative assistant spent a total of 80 hours working during a 2-week period. Determine the range of time that the administrative assistant could have spent in meetings. Okay, so go back to the beginning part here. So I'm going back to my original problem again. Administrative calculated that he spends more than 13% and less than 17% of his working hours in meetings. So I know that we have 80 hours, right? So this represents my H. That's the same H that's in my equations. So I'm going to go ahead and substitute that into both of my inequalities. So I have M is greater than 0.13 times 80. And when I do that, that would give me, oops, let's see. That would give me 0.13 times 80. That gives me 10.4 hours, right? So M has to be greater than 10.4 hours. So he's going to work more than, or he's going to spend more than 10.4 hours in meetings, but then he's also going to spend less than 0.17 times 80. So let's do that. 0.17 times 80. And that would be M is less than 13.6. So basically what we're saying is this. It's greater than 10.4, but less than 13.6. So we can say that the administrative assistant spent more than 10.4 hours and less than 13.6 hours in meetings, or you could say they spent between 10.4 and 13.6 hours in meetings. Okay, so hopefully this helps you with doing these practice problems. If you need a piece of scrap paper when you're doing them, make sure that you have that handy. And make sure you complete that assignment. We'll see you next time. Thanks, everyone.